talk about cause of decrease. Why we just mentioned the mortality rate is going down, and that slope we like to push even harder to go down even further. And up to now, we already mentioned early detection, right? Because mammogram, colonoscopy, and so on. And then the other one is cancer education. Don't smoke. Don't eat benang, right? And of course, there are better clinical care. That should be a major contribution. But the other area, which is the one I personally working on it, and that is target therapy. In the last decade or so, there are a lot of amazing therapy who now been developed, and I'm going to share with you some of the real story, and that is very exciting. I'm already excited now. First story I want to share with you, Gleevec. There's one type of leukemia called CML. This type of leukemia is, this leukemia originated before 2001. When the patient was treated, they had to go to bone marrow transplant, daily infusion. How many people, I'm sure none of you have done that, but if a relative or friend has gone through bone marrow transplant, it's very brutal. Bone marrow transplantation is not something you're going to like it. It's very brutal procedure. And even you do that, the 5-year survival rate is 30% before 2001. And scientists in 1982 discovered the reason why this disease was become a CML disease, because there's a gene, oncogene called abelson. That gene, the chromosome translocation, and become a fusion gene. It's a very famous chromosome translocation called Philadelphia chromosome because it was discovered in Philadelphia. Chromosome 922 translocation and make a gene become activated oncogene. And that one is a tyrosine kinase called BCR-ABL. And then that was 1982. And 20 years later, people work on that inhibitor, develop, and FDA finally approved that drug to treat this disease. And this one, I still remember, at that time, it was so exciting for cancer field. Because when the phase 1 clinical trial started, out of 54 patients, 53 of them, how many percent you count? With CML has complete response. Let me repeat it. I don't have to repeat it. Come on. 53 out of 54. And phase 1 clinical trial. For those of you who know, usually when a new drug came out, when you do phase 1, what does phase 1 mean? Phase 1 is difficult to do. Cancer phase 1, pretty much the patient are those patients who has no any hope. And so we tell them, I'm sorry, I don't have any drug now. But there's a new drug under development. We don't know if it's going to work or not. But in the animal model, mice, it looks like being cured. Would you like to try it? Hey, they had to agree. If they don't agree, you cannot put them in a clinical trial. Phase 1 clinical trial is very difficult to do. I'm not a clinician. I'm a scientist. But I've developed drugs in phase 1 trial, and it's very painful. Because I was an MD, and when I developed drug to phase 1 trial, the patient or patient's relative, hey, can I talk to Dr. Hong, who is the discoverer of this drug? Then, of course, you talk to them. You explain to them, you get excited. But phase 1, virtually all patients die. That's why it's called phase 1. Because phase 1 are those stage 4 patients who has no any available drug, and they are very sick, their immune system are very weak, and they're going to die, then we tell them, would you like to contribute to scientific development? There's no guarantee it will work, but your contribution will help scientific development. And every anti-cancer drug went through this procedure. So some of the patients would agree to participate in phase 1 clinical trial. And that's called phase 1. My friend, this is phase 1. Anybody want to complain? That was almost cry when you see this data. Phase 1. Okay, now, recent data, this disease, of course, this drug has been modified, has been improved better and better. 98% survival rate for 6 years. 98%. And 95% for 8 years. And this data is similar to this population. We are not sick. What does that mean? If you like, you can use the term cure. And this particular, I'm not working on the leukemia. One time I gave this type of talk in the Houston Chinese community. And after the talk, there was one gentleman. He brought a high school lady, a girl, come to talk to me and say, hey, Dr. Hong, you have a very nice talk, but thank you so much. I said, what? He said, oh, because my daughter was cured by this drug. And I told him that, well, congratulations, but I didn't develop this drug. I'm not working on this drug. But he said, but the reason I come here to say thank you because I appreciate you guys, people like you are doing this kind of stuff. So that was very rewarding. That was very rewarding because that's somebody's life, and it's a high school kid, and that's this drug. This is a very good example. And unfortunately, I was not involved. Well, I should not say unfortunately, come on. We should feel happy that. The other one I want to share with you, which I'm involved. This gene in the mid-80s, 1980, is a very two famous paper in Science, in breast cancer, in ovarian cancer. I don't know, somebody in the audience might know this gene called HER2, for those people who know the breast cancer. This gene, either by measure gene amplification in cancer, or by looking for the expression label called overexpression, the survival rate is always low. It is a high expression, low expression, high expression, low expression. They are all breast cancer. They are all breast cancer patients, but if you have this gene overexpression, that's the survival rate, much lower than this. And if ovarian, even worse. That's the curve. That's the curve. If ovarian, that's what I tell you. If you ovarian cancer patient in 1980 and HER2 was overexpressed, you're dying, period. 1 year. And I have many patients, I'm not a physician, I have many friends who die with disease like this. And this gene is called human HER2, and in the animal it's called NEW. And when I was a postdoc fellow, I was involved in cloning of the new oncogene. And that's why I was working on breast cancer ever since then, because I have been working in this field. Okay, so that is the disease that in 1980 is no cure. But now, that's in mid-1980. In 1998, Genentech developed a substance, and this is a very famous drug. In Chinese translation, He. This is a monoclonal antibody drug targeting that particular molecule. It was approved in 1998. So this drug is a little bit luckier that when the gene was discovered, it was mid-1980, 1985, 86. We cloned in 1986, yeah. And then after a little bit longer than 10 years to target this particular molecule, and FDA approved, it became an official FDA-approved drug. Pretty expensive, though. However, all these are so-called target therapy, meaning breast cancer, 20% are HER2 positive, or ovarian cancer, 20% are HER2 positive. If you are HER2 positive, then you can treat with this drug. But not every HER2 positive patient, the drug going to work. Only 1/3 of patients respond. At that time, we don't know why. And if this drug is only a few dollars, it's okay. One cycle is $65,000 US, and only 1/3 respond. And if I have HER2 positive breast cancer, and I had to pay $65,000 for one cycle, and I may have to go to 3 cycles, I calculated $200K US. If I belong to that two-thirds, what should I say? You say, piss me off or what? So, back to the lab. Now, 5-year survival rate is 60%. Now, in the laboratory, many people, including scientists in MD Anderson, I'm involved, and my colleague together, now we have developed, we improve this drug, we have do the combination therapy, and today we don't talk about science, but just say we improve that now. So now, if you are HER2 breast cancer patient, if you go to MD Anderson, 80% survival rate. I'm not saying it depends on which hospital you go, okay? MD Anderson is slightly different, okay? That's why it's the #1 cancer center. You witnessed that. In mid-1980, I was involved clonal. And then after that, when my friends say have HER2 positive, one by one die. But now, I cannot say this disease is cured. But nowadays, if a lady diagnosed breast cancer, the first thing I pay attention to it is the ER positive or ER negative. ER positive is good. If it's ER negative, it's HER2 positive or negative. If it's HER2 positive, not too bad. I didn't say congratulations, but I know it's not bad. Well, actually, you could say that. But if they are ER negative and HER2 negative, so-called triple negative, now I don't know how to deal with it. And no, today we don't know how to deal with it. I guarantee you, 5 years, something is going to come out because many people work on that. And we have a lot of hope. And then the reason I'm so confident is first, I witnessed this kind of stuff. And also, we know the mechanism. We design the drug. We don't look for a drug, just go to 山上找仙丹. No, we know the mechanism. We design the drug. So triple negative breast cancer, 5 years, something is going to come out. Anybody want to bet? And this is another interesting drug.